So now we're going to talk a little bit about the notation that you'll see here. So really just kind of ignore this on the right. That's going to be for the future assignments. Definitely very important in the future assignments. But for now, just looking at this, we've talked about how the antiderivative gives us the area under the curve. So let's talk about the bounds a little bit. So A is our lower bound. Whatever here is down here on the bottom, that's the lower bound. That's going to be on the left. And the right bound will be on the top here. So this is telling us the area from A to B. So from A to B of f of x. Be careful what functions placed here as things get more complicated. On this assignment, it's just going to be f of x. But in the future, you might run into f prime, f double prime, or, things like that. So be careful what's there. Don't just assume that we're always doing the area under the curve of what's given. Just realize that, that it is the area under the curve of whatever is stated here. So in this case, it is f that's stated here on the graph. Here it's f stated here with the integral. Remember, this is called an integral from A to B. From A to B. All right. So if you run into this graph, the graph of the following function of f, let g of x equal, so we need to find g of 2. Well, let's start by plugging 2 in. Remember, this is g of x, right? And know there's a t dt in there. But x, 2 is replacing g of 2 would mean that the x gets replaced with the 2. So we're going to replace the x. Notice x is the upper bound in this case. I think it's going to be the upper bound in all the cases. So we're going to be finding the area under the curve of f of t dt from -2 to 2. So the area under the curve from here to here. And you're going to want to just, kind of like we've done in the past, break this into geometric shape so we can find the area of. So -2 to 2, that's 4 by 4, so that's 16 for the area there. And then 1/2 base times height, that's a 1 by 1 triangle, so we're going to put 0.5 for this little one. That's half, right? 1/2 base times height. So g of 2 is going to be 16.5 if you add those areas together. Let me just double check, make sure I did that right. -2 to 2, that looks good. And away we go. Same thing here. Plugging a -1 into the bound. Let me see. Let me do this one. G of 3. So we're going to be evaluating. G of 3 will be from the integral from 0 to 3 of f of t dt. So we're going to find the area under the curve from 0, which is right here on the y-axis, to 3. And I'm going to section off those triangles and rectangles there. So, just from the rectangle, it's a 3 by 4, so that's 12. And then this top triangle here is a 2 by 1. 1/2 of 2 is just 1. And then this we see again is the 1 by 1 triangle, so it's 1/2 base times height to get 0.5. If you forgot, 1/2 base times height is the area of a triangle. So you find the area of the square that it lives in, cut it in half. I mean, you could literally see the rectangle that this exists in. Find the area of the rectangle, just cut it in half. So very simple formula. And that's it for this assignment. Pretty simple. Here we're going to get into, some of what we saw up here, and it's all going to come together, but you do need to get used to those bounds and how they work, and that we're finding the area from -2 to 2. We're basically, if our bounds are -2 to 2, we're finding the area from -2 to 2 there.